From the beginning, the laws of physics have controlled the fate of mankind. To survive, he had to understand and exploit the forces of nature, instead of being a helpless victim of them. The successful career of Homo sapiens began when he first found he could put mechanical forces to his own use. He made rapid strides in crafting tools and weapons. One of the basic needs in every society has always been an accurate and accepted system of weights and measures. Over the centuries, scientific research has opened up new ways of putting the laws of physics to use. Continuous improvements to measuring methods have been a powerful factor in the progress of civilization. Whereas calibration in manufacturing was more by rule of thumb, things today are totally different. Series production demands repeatability. Modular components must be a perfect fit, and international cooperations require precise standardization. We also know that we must make sparing use of our finite resources. For all these reasons, it is essential to use sophisticated weighing and measuring instruments that are capable of high precision metering and of measuring extremely small differences to any number of the decimal places. Wherever mechanical forces are applied, precise measurement is the starting point for maintaining safety standards, improving production techniques and products, and furthering the advance of science. There is no margin for error. Advanced methods for weighing and measuring and a high degree of computerization is the answer. For accurate calibration, in research and development, and in complex process monitoring systems. It's a good thing there's something that stops at nothing to get things right. (1950) saw the startup of a small company whose products were to set completely new standards in the electrical measurement of physical quantities. Here in Vogtlereuth in Bavaria, Germany, the engineer and former aircraft designer Karl Hottinger began producing measuring instruments. Hottinger soon made a name for himself with his inductive displacement transducer and plunger. Used in combination with another Hottinger invention, a carrier frequency measuring amplifier, this contactless instrument represented a major breakthrough in the measurement of force, displacement, and vibration. With growth came a new location in Darmstadt and a partner. Karl Schenk was a mechanical engineering firm, and the alliance made it possible to produce all components for the Hottinger measuring instruments in-house. The company began manufacturing universal strain gauges. To expand its know-how in strain gauge technology, Hottinger came together with the U.S. instrument maker Baldwin Lima Hamilton Corporation in 1963. The new company was named Hottinger Baldwin Messtechnik HBM. In 1969, the first men landed on the moon. HBM strain gauges were there too. In 1972, at the Munich Olympics, our technology took part with the athletes in the 100-meter finals and was used to check the construction of one of Munich's landmarks, the roof of the Olympic Stadium. In the mid-1970s, with the Kreutzer circuit, HBM moved into a new dimension in calibration and research technology. The circuit, named for its inventor, HBM's head of R&D, Manfred Kreutzer, uses field effect transistors to achieve the strain gauge. It was the first time transistors had been used in this way anywhere in the world. This innovation sharply increased the exactness of measurements and at the same time made the instruments more compact. The force transducers and load cells that HBM supplied to OEM manufacturers made possible the production of high-precision scales and metering systems. In 1975, HBM strain gauges, displacement and force transducers monitored the movement of a historic monument weighing 15,000 tons, St. Mary's Church in Most, Czechoslovakia. In 1976, Hottinger Baldwin developed the first calibration laboratory for the German calibration service. In the 1980s, we were quick to see the potential of microchips for miniaturization and for boosting the performance and user-friendliness of our products, such as during bridge load testing. 1986, HBM became the first German organization to gain ISO 9001 certification for its quality management systems. In the 1990s, we gained an accreditation for excellent environmental management. HBM weighing, measuring, and system technology has been setting standards for 50 years, and we intend to continue this way. This tiny thing has made us great.
How?
The basic principle is simple. Through the expansion of this small metal strip, you can measure or weigh anything with the greatest accuracy.
Wow.
Provided, of course, you have the necessary weighing and system technology from HBM.
Can you weigh a mosquito or an elephant?
Sure, if need be, both of them at once. You'll find HBM load cells just about everywhere there's something to weigh, because HBM load cells can take punishment without losing even a milligram of their sensitivity. Companies across industry rely on our technology in weigh bridges, container weighing systems, and platform scales, post office scales, shop scales, counting scales, doctor's scales. High tech from HBM provides the added plus in precision. We can find totally new ways to weigh, customized for your needs. When it comes to fill level monitoring, it is often important to be able to meter even very small amounts with the utmost reliability. The high quality of HBM products and the high repeatability of the results eliminate the risk of errors. HBM can offer a solution for anything that needs to be weighed. It's our promise to you, worldwide. Strain gauges are still our core product and the basis for one innovation after another. They are simple and robust, small, but extremely versatile. They are easy to use, and they guarantee high accuracy at low cost. A measuring device built around an HBM strain gauge has a built-in competitive advantage, and it doesn't matter whether you want data on volume, rotation, force, stress, or acceleration. There are many different circumstances where it is important to measure the internal stress of some material. For example, high-speed drilling systems are fitted with a non-destructive measuring system to determine the internal stress, and thus the load capacity of cast or rolled steel components. Experimental mechanics couldn't do without strain gauges. They are essential to determine the strain in just about any kind of material, and you need to know these facts in order to get safety standards while at the same time making optimal use of energy and material resources. Strain gauges supply essential data for aircraft designers and are used to monitor material stress during flight trials. High-speed trains, like the Transrapid, undergo similar testing. Applications range from the measurement of highly dynamic signals to static monitoring tasks. Typical examples are measuring machine forces, load testing during building restoration, such as at the Frauenkirche in Dresden. Automotive manufacturers and parts suppliers rely heavily on uncompromising accuracy of HBM measuring systems to monitor production and assembly of safety-critical parts. Modern drive systems undergo tough performance testing to ensure the optimal dynamics, safety, and cost-effectiveness. And you'll look a long way to find an automotive test rig without HBM components and systems. Worldwide, HBM is setting new standards whenever the challenge is to measure mechanical dimensions electrically. Thanks to our calibration system, all HBM testing devices meet the highest quality standards. We are uncompromising also in the traceability to the different national standards. Our products are used for reference purposes by international metrological institutes. Our laboratories are available for EMC testing, as well as calibration as part of the German calibration service. The highest authority on physical measurements, the PTB, the Federal Physics Office, uses HBM precision instruments. Worldwide, our measuring devices are in use by national standard laboratories to compare force and rotation measurements in France, England, Italy, the USA, Japan, as well as Korea, China, and Australia. What better evidence could there be of our internationally renowned position as leaders in the service of compliance and traceability of industrial norms? HBM weighing and calibration specialists work very closely with our customers to find the right solution for every problem. The problems that are brought to us are diverse. Sometimes it's just a question of supplying the right part. Sometimes the answer is a complete measuring system, including sensors, electronics, and software. Our ultra-modern production facilities in Darmstadt, Germany, Marlborough, USA, and Suzhou in China guarantee unmatched product quality. All facilities are in-house, from research and development to design and production. We cover all aspects of the supply chain. Manufacturing of transducer and sensor banks, development of strain gauge technology, and production of signal conditioning electronics and software. We'll design a circuit board layout or a complete modular system with thousands of measuring units. And our skill and experience also goes into making our instruments as compact and user-friendly as possible. Our proprietary Catman software makes it easy to use, analyze, and present the captured data. A final quality control under extreme climatic conditions. A tough test at the beginning of a long life. No device leaves our plants without passing this test. Each transducer is provided with the specific resistance for its calibration. You might carry this idea further and say that individual and specific is also the way we treat our customers. A highly trained staff in more than 60 sales offices and outlets on 5 continents work closely with each customer to find a solution. Seminars help our experts keep their knowledge up to date. HBM is closer than you might think. Visit our website and do business with us via the internet. Challenge us to solve your measurement tasks, large or small. Our strain gauges are built into equipment all over the world. The chances are you're already using one. You just have to know where to look. HBM, measurement with confidence.